All right. So, hello, my dear students. My name is Benatang Paton, and I welcome you to the channel Classroom, where we learn together. So, what's new? Yes, the year is 2026, so it's a new year. We are already in the month of February. But what is new is that you are now in class 10. So, you have overcome. Okay, is it overcome or overcome? You have overcome. Okay, so you have overcome class 9, and now today you are in class 10. So a very, very big congratulations to you for making it to class 10. But let me tell you that your journey has just started. Okay, class 9 was not easy. Yes, class 9 was not easy. Class 9 was tough. It is actually very, very tough. But class 10, okay, but class 10 is interesting. Class 10 is actually much easier. If you have made it out of class 9, then I guarantee you that you can make it out of class 10 again. So don't be disheartened, or don't be afraid of class 10. Class 10 is very much easy. It's very much easier than class 10. It is very much easier than class 9. Since you have passed class 9, you can easily make it out of class 10. But then what is important in class 10 is that you have to do your very, very best, because you are going to write for board exams. So board exam, metric exam, okay, it's a very, very important and a very crucial part of your journey ahead. So everything starts with class 10. So I want you to put your 110 focus. I want you to give your best. I want you to study. I want you to practice. I want you to invest your time in books for this year. Okay, 2026, you have to say to yourself that I will study and I will change my habit and I will be dedicated to my books. If you don't do like that, then it's going to be a very sad story for you. So you have to start from now itself. This is the second month of the year. So start from now itself, okay? Don't lose even a single day. All right? Pray to God. Seek His wisdom, because God is the provider of wisdom. God is the provider of understanding. He will give you wisdom. He will give you understanding. So seek His wisdom, seek His understanding, and He will give you. But then you and I, we have to do our part. So I have to do my part, and you also have to do your part. So remember that you have to do your part. And what is your duty? And what is that you have to do? You have to study. You have to go to school. You have to take down the notes. You have to study the notes. You have to do your assignment. You have to do your projects. And that's how the year will go. And by the end of the year, when the exams are near, if you have been doing these things seriously and sincerely, you will be ever ready to write the exam. So that's what I want to tell you. From this day itself, okay, from this moment itself, make up your mind and decide that I will do better. So that is a promise which I want you to keep. So is that a promise? Is that a promise? Yes, that is a promise. And remember, do not go back on your promise. All right? So, all right. With that positive note, let us start our class. So we will be starting with chapter 1. The name of the lesson is Chemical Reactions and Equations. A very easy lesson, okay? A very easy lesson. So by now, I guess your teachers have already done this, because we are already in February. Today is 19th, okay? So, so it's a easy lesson. So in today's video, I will be giving you the introductory session. So in today's video, I will teach you chemical reaction, definition of chemical reaction. We will be studying what makes up a chemical reaction, which is reactants and products. Then we will also do a brief revision of physical change and chemical change. And then we will wrap it up with exothermic and endothermic chemical reaction. Okay, so without wasting further time, let's go directly to the lesson. But before we go into the lesson, one rule, okay, which I always encourage my students to follow in this classroom, is that you have to grab a notebook, you have to grab a pen or a pencil and take down the notes. Whatever we are discussing here, let that serve as an additional notes. You are already getting notes from your teacher, okay, from your school teacher, your school's miss or madam or miss, sir, madam or miss. You're getting notes. So that is your primary notes, but then this also should serve as a notes for you. So this will also be important. So kindly take down these notes also. Okay, so let's start. the first thing that we will discuss is we will define what a chemical reaction is. So let's define together what is a chemical reaction. So define a chemical reaction. Define a chemical reaction. Now, I will say that I don't have the best handwriting. Okay, so please do bear with my handwriting. My handwriting is definitely not at all good. But then we are here to learn. Okay, so please don't mind my handwriting. If it is understandable, if it is readable, then okay, that's what matters, isn't it? Okay, so what is a chemical reaction? Define a chemical reaction. So one of the simplest definition of chemical reaction is a chemical reaction is a process where new substances are formed. Okay, that is a simple definition. A chemical reaction is a process where new substances are formed. All right, you can pause the video and you can write it down. Okay, but I'll be giving you a better definition which will help you score better mark and which is actually more detailed. So the simplest definition is a chemical reaction is a process where new substances are formed. All right. Now, but the definition that I'll be giving you will be a chemical reaction, because we need to score more marks, isn't it? We have to impress our teacher, isn't it? You have to impress your teacher. If you don't impress your teacher will not give you marks. Understood? So you have to impress your teacher. So a chemical reaction is a process where one or more substances called reactants change into one or more new substances called products. So this, my dear students, is the definition of a chemical reaction. A chemical reaction is a process where one or more substances, that means there can be one or more substances called reactants, very important. This is a very important word. Change. Okay, so there will be a change. A chemical reaction is a change into one or more new substances called products. Another very important word. So now we will be talking about these two words, reactants and products. So what is a reactant and what is a product? Let's understand that. So reactants and product. Now see, my dear students, let me just write a chemical reaction. I'll use a simple chemical reaction. For example, carbon, C plus O2. This arrow indicates that the chemical reaction is going on. So this is carbon, C plus O2. Now, what you'll get, the chemical reaction will take place and you'll be getting CO2. Okay, I'm not balancing this. Okay, oh, it's already balanced. Yes, one carbon, or two oxygen. It's already balanced. Now, see, this is an example of a chemical reaction. Now, let us understand what reactants are and what products are. Now, see here, my dear students, reactants are those substances, which undergo chemical reaction. I repeat, reactants. Reactants are those chemical substances, which undergo chemical reaction to give products. So, reactants are those substances which undergo chemical reaction. In this chemical reaction, carbon and oxygen are the reactants. So, these two are the reactants. I repeat, reactants are those substances which undergo chemical reaction. So in this chemical reaction, carbon and oxygen, they are the ones which undergo a chemical reaction, and then what do they give? They give this. What is this? This is a product. So this is a product. I hope it's clear that in every chemical reaction there will be reactants and there will be product. Without reactants, there can be no chemical reaction. I repeat, without reactants, there can be no chemical reaction. So if there are no reactants, if these are not there, now you tell me, from where are we getting carbon dioxide? From where are we getting CO2? Think, does it make sense? Without the reactants, from where will you get CO2? There has to be something which should contribute to this, isn't it? So products can only exist when there are reactants. Are you following? Are you following or not? Without reactants, see, there's nothing here. Without reactants, there cannot be any product. Since there are no reactants here, there cannot be product also. So there cannot be any product. And if there are no reactants, okay, then how can there be a chemical reaction also? So there is nothing here, empty. So no reactants, no product. Simple, isn't it? But then we are discussing about chemical reaction. So let us do a chemical reaction. So let us take one example of chemical reaction. So let us take carbon, and then let's take oxygen. Let carbon and oxygen undergo chemical reaction. Okay, so they will react, which is shown by this arrow. Okay, and what you will get, since carbon and oxygen are reactants, they will give us a product. So they will give us a product. We get CO2. What is CO2? It is a product. It is a product formed by these two reactants. I hope you have understood. Okay, another way to remember, okay, where I want you to use your eyes. So I want you to remember how to identify the reactants and product. One simple trick I'll give you. So remember, this arrow indicates chemical reaction. So whichever thing is in front of this pointer, this is the arrowhead, isn't it? This sharp pointy head. So this pointer, this head, let's call it the head, and we'll call this the tail. We'll call it as a tail. So whichever is in front of this head, is always the product. And on the other side of the head, this part, the tail, the blunt side, we call it the blunt side, isn't it? Blunt means it's not sharp. This is sharp. This is the pointy part. This is the blunt part. It is not sharp. So these are the reactants. If in exam they ask you to identify which is the reactant, which is the product, then I want you to be able to identify, just by looking at the reaction also. If your teacher has provided you this reaction, then, and the teacher is asking, identify the reactants and the product in this chemical reaction. So you can always look at this arrow. This arrow indicates the chemical reaction, and also it indicates the direction also. So we have the reactants, which give you the product. So remember, whatever is in front of this arrowhead is the product. So you know this one. Pay attention to this arrowhead, So next time you see a chemical reaction, just pay attention to this arrowhead. Whatever is in front of this arrowhead is always the product. So if the arrow is like this, provided the arrow is like this, because in higher classes you will get sometimes arrows like this. These are reversible chemical reactions. So remember, the arrow has to be like this. Provided the arrow is like this, understood? Provided the arrow is like this, whatever is in front of this arrowhead is always going to be a product. Clear? Then what will this be? Now that you know that these are the product, then what are these? Correct, these are the reactants. See, you have understood, isn't it? So I hope it's clear what reactants and what products are. So once again, remember that a chemical reaction is a process where one or more substances, called the reactants, change into one or more new substances called the products. So here you can see this is carbon. Carbon is an element. It has atomic number 6, and this is oxygen. Oxygen is another element having atomic number 8. So carbon, this is carbon, this is oxygen, and what we are getting carbon dioxide. where carbon and oxygen together have bonded excuse me, and then they have formed a product which is carbon dioxide. Whereas here on the reactant side, both of them are separate. Okay, they are not mixing here. Okay, here carbon is purely by itself, and here this is pure oxygen. So here mixing has not been done, reaction has not been done. Okay, but they will undergo chemical reaction and a new substance will be formed. Which is a new substance? This is new, isn't it? This is new. Here we have both carbon and oxygen together, which you do not see here. Here they are separate. Here they are separate. Here carbon is separate. Here oxygen is separate. But here you will find that they have combined together. So we are getting a new substance. This is a new substance, which we call the product. I hope it's clear. Clear, isn't it? All right. So let's proceed to the next one. So we have just defined a chemical reaction, and in a chemical reaction we talk about a change. So let us focus on this word, change. Now I'm going to erase this, so if you have not written it, pause the video and you write it down. Okay, so now we will talk about change, what a change is. So you have learned about this in class 8. I have not seen this in class 7 science, or maybe it's there. So in your lower classes you have studied about changes. There are two types of changes, so let us do a quick revision of those two types of changes, which are called physical change and chemical change. So let us do a review. Okay, a quick revision, but before that let me write what a change is. So a change is a process. It is a process in which the final state of a substance is different from its initial or original state. So this is the definition of what a change is. A change a change is a process in which the final state of a substance is different from its initial or original state. This is the definition of what a change is. Okay, now there are two types of changes, physical change and chemical change. So let's learn about these two types of changes. So let us put up a division here, and here we will write physical change. So let's talk about physical change here. Physical change. It is very important for you to know how to differentiate between a physical change and a chemical change. Many students, forget about many students, even me, I was never serious about this. So even I had a wrong idea of physical change and chemical change. Okay, so it's confusing. So we have to be very sure of like physical change and chemical change. Then here we write chemical change. Chemical change. So how do we differentiate between a physical change and a chemical change? Let us write down the points first. So point number 1 under physical change. Number 1, no change in chemical composition. In chemical composition. That is point number 1 for physical change. Point number 1 for chemical change, change in chemical composition. Change in chemical composition. Point number 1. Then let's go to point number 2. Change in physical properties like change in physical properties like, what physical properties they are? Shape, comma, size, comma, physical state. Point number 2 for chemical change. Let's write down for chemical change. Point number 2. The point number 2 is same for chemical change also. Change in physical properties like shape, size, physical state. Shape, comma, size, and physical state. So the difference between a physical change and a chemical change, this is how it is. So let me just step to the side and let you pause the video and write down. All right. Now, point number 1, under physical change, no change in chemical composition. Very important. There is no change in chemical composition in physical change. So in a physical change, there will be no change in chemical composition. Whereas in chemical change, there will be a change in chemical composition. Very important point. Okay, so point number 1 is very important. So in physical change, no change. There is no change in chemical composition. So let us now take an example. So for physical change, which example should I give you? Example, melting of ice. So let's write down some example. Okay, example, melting of ice. Melting of ice. Now let's discuss about this. Is melting of ice a physical change? Let's study together. So what happens when ice melts? So ice, let's say this ice. So this is an ice block. So this is ice. Now ice, when it melts, then it will become water, isn't it? It will become water. So it will become liquid. It becomes liquid. So is this a physical change? In order for it to be called a physical change, so there should be no change in chemical composition. So this is ice. Ice is water, yes. So it is water, H2O. Now this is liquid water. This is liquid water again. So is this water or not water? This again is water. So ice is also water, whereas this liquid, okay, when ice melts and gives you water in liquid form, that is also water. So here also water, here also water. So there is no change in chemical composition. Here also this is water in the form of solid ice, and here also it is water in the form of liquid. So both are water only. So this is an example of physical change. In physical change, no change in chemical composition. So a change has taken place, but then the chemical nature has not changed. This is still water only. Here also water, this also is water. I hope you understood. Okay. Now, in physical change, there can be change in physical properties like shape. So the shape of water in ice, which is in solid form, it will be like this. It will have a shape. Okay, it can be it depends on the shape of the container from where you're freezing it. Okay, so it can have a shape, but in liquid form it will, okay, the shape will change again. So there can be a change in the shape. Okay, there can be a change in the physical state. In physical change, the physical state of the substance will change. So ice, which is solid, this is in solid state. When it changes to water, in which state is this? This is in liquid state, isn't it? So the physical state has changed. Okay, so in physical change, the state may change in physical change, shape may change. Okay, for the size, I will use another example. Tearing of paper. Tearing of a paper. Tearing of a paper. So if I tear a paper, do I have a paper here nearby, which I can actually tear and show you? Let me check whether I have any loose paper here or not. If I have one, I'll use. But I wonder whether I have. Oh, very sorry. I did not keep any loose paper. Let me check. Can I tear them? I don't want to. I need to have a paper. Let me check another textbook. So, unfortunately, I don't have a paper here. I don't even have a rough paper here. Right, I'll bring one paper. So, here I have a paper. This is a graph paper. So, this is a paper. So, look at the shape of the paper, okay? So, it's like this. Now, if I tear it, what happens? Now the shape I have distorted the shape, isn't it? The shape has changed. Previously, its shape was like this, but now I have torn it, so this is a new shape. I can still change the shape. So, what am I doing? Am I not changing the shape of the paper? Yes. What is this? Is this a chemical change or a physical change? This is a physical change, because see, before tearing also it was paper. Even after tearing also it is paper. I can keep on tearing, but still then it is still paper. So this is an example of physical change. Okay, so this is what physical change looks like. In physical change, there is no change in chemical property. So this is still paper. Understood? Next, we will go to chemical change. In chemical change, there will be a change in chemical composition. So the chemical composition will change. Example of chemical change will be what do I give you? Rusting. Yes, rusting. Rusting of iron. So rusting of iron is it's a chemical change. Let us write a reaction here. So rusting of iron. So we have iron here. So iron, we know that iron reacts with oxygen. So Fe plus O2. So what will happen? A chemical reaction will take place, and what do we get? We will get Fe2O3. This is ferric oxide. This is iron. Okay, this is the elemental iron which is found in the periodic table. This is oxygen. So iron reacts with oxygen, and then what you get? You get ferric oxide. So here you will see that this is a new product. This is a new product. Its chemical composition has been changed. This is pure iron. This is pure oxygen. Both of them are separate here. Iron is separate, oxygen is separate. But after undergoing chemical reaction, you see that both of them are together. So this is a new substance. So this is a new substance with a new chemical formula. Okay, this is Fe only. This is oxygen only, but here you have Fe2O3. So this is a new chemical formula. That means this is a new substance. Okay, so there is a change in chemical composition. So the chemical composition of iron and oxygen, okay, the chemical composition of iron and oxygen, they have combined together here and given you a new product. So there has been a change in the chemical composition. All right, so here iron and oxygen, they have combined together. Previously they were separate, but after undergoing chemical reaction, they've become a product together. So there has been a change in the chemical composition. I hope that's clear. Okay, so remember that. Whereas point number 2, there can be change in physical properties like shape. So the shape also can change, size also, and even physical state. Okay, so even in chemical changes, we can observe change in the shape, change in the size, and change in the physical state. All right, so I don't think I've forgotten anything. So you have to remember this. You have to remember that even in chemical change, you will observe change in shape, change in size, and change in the physical state. I hope that's clear. Okay. Another example I can give you is burning or combustion. So combustion of charcoal. Charcoal spelling is CHAR. CHARCOAL. So charcoal is a carbon. So I'll be writing C for charcoal. Okay, charcoal in Nagamese is koila. Okay, it's winter season, and maybe some of you maybe you may be burning koila at home. Okay, so that blackish substance isn't a koila, we call it. So burning of charcoal. So charcoal is carbon, so I write C plus combustion. It takes place with oxygen. So what you get CO2 plus heat. Okay, so this also is an example of chemical change where there is a change in chemical composition. So carbon reacts with oxygen and gives you carbon dioxide. So this is the change in the chemical composition where carbon, which was alone, independent, oxygen alone, independent, they underwent chemical reaction and now they are together. So this is the change in the chemical composition. So I hope you have understood. Okay, I'm about to erase it, so let me go aside. You can pause the video and take down the notes. All right, so assuming that you have written it down, I'm going to erase it. And now we will talk about the characteristics of a chemical reaction. That will be the next topic. So, characteristics of chemical reaction. Let's study about the different characteristics which will help us determine whether a chemical reaction is taking place or not. So, characteristics of chemical reaction. There are four. Okay, there are four characteristics which we should look out for. The first one is, number one is change in state. Change in state. So if a change in state is happening, say from solid to liquid or from liquid to gas or from gas to solid, any change in state is an indicator that a chemical reaction is happening. So that is the first point. Second point, it is the change in color. Change in color. So if we observe a change in color, okay, in the product, then that is also an indicator that a chemical reaction has taken place. The A, B, C. Point number C is the evolution of gas. Evolution of gas. Evolution of gas means production of gas. So in any reaction, if we see gases coming out or if gases are being produced, that is also an indicator that chemical reaction has taken place. Then the fourth one is the change in temperature. Change in temperature. So if in any reaction, if you observe a change in the temperature, okay, if you observe a change in the temperature in the product, then that is also an indicator that chemical reaction has taken place. Now we are going to focus on this point. So this change in temperature, okay, we are going to focus on this point. So on the fourth point, which is change in temperature, we can study two types of chemical reaction here. One is called the exothermic chemical reaction and the other is called the endothermic chemical reaction. So let's learn about those now. So let us learn about the two types of chemical reaction based on temperature, which is exothermic chemical reaction and endothermic chemical reaction. So this is based on temperature. So basing on temperature, we can study chemical reactions, okay, into two parts. One is the exothermic, the other is the endothermic. So we have the exothermic chemical reaction, and the other is the endothermic chemical reaction. Now, there is a, well, students find it very confusing, okay, like most of the students, they find it confusing which is exothermic chemical reaction and which is endothermic chemical reaction. So let us try to understand this. See, so thermic means heat, okay, so they are both related to heat, only, okay. No, so since this means heat, then you have to understand what they mean. So what does exo mean? Exo means exit, okay. So remember this, my dear students, that exo means exit. Exit means going, okay, releasing, okay. Exit means going out, okay, going out. You know the meaning of the word exit, isn't it? Exit means going out. You always go out, you always step out of the building through the exit door, so going out, okay. So if exo is exit, then endo, okay, endo will be the opposite of exo. So endo means enter. So you have to know this, okay, you have to know this. This is how you have to remember in exam. Exothermic, exo, ex, isn't it? Ex, exo, ex, exit, okay. Ex, the same ex is found in the spelling of exit. So ex, okay, for exit, and en for enter. I hope this will help you. En, enter, endo, en, okay. Exit, ex, exo, ex. So this should help you remember quickly in exam, okay. And then you should remember, okay, that chemical reactions which releases heat as they proceed are called as exothermic, means they give out heat. Heat is going out, okay, heat will go out. So the chemical reaction will release heat. Such type of chemical reactions are called exothermic chemical reaction, where heat is released, where heat is given out, where heat exits, okay, where heat exits. The other one is endothermic chemical reaction, where heat is absorbed, okay. Chemical reactions which proceed by absorbing heat are called as endothermic chemical reaction. So here heat will enter into them, okay, heat will enter, that means they will absorb heat, okay. So they are absorbing heat, so absorb. So chemical reactions which proceed by absorbing heat are known as endothermic chemical reaction. We will write a proper definition of it, so don't need to worry. So exothermic and endothermic, let us study like this. We will study here exothermic chemical reaction. Exothermic chemical reaction. Exothermic chemical reaction. And here it will be endothermic chemical reaction. So I'll give you the definition now. So let us first write down the definition. So the definition: chemical reactions which proceed by releasing heat. Now heat is a form of energy, so you write heat energy, are known as exothermic chemical reactions. Now let's write down the definition for endothermic chemical reaction. sorry, the I is here. The definition goes chemical reactions. Well, everything is going to be same. The only difference is instead of writing releasing heat, I will use the word absorbing heat. So chemical reactions which proceed by, it should be absorbing heat, okay? By absorbing heat. You can say heat energy, because heat is a form of energy, are known as endothermic chemical reactions. Are known as endothermic chemical reaction. So this is the definition of endothermic and exothermic chemical reaction. First, exothermic chemical reactions. Exothermic chemical reactions are those chemical reactions which proceed, means the reaction goes forward by releasing heat energy. That means as the reaction proceeds, they release heat energy. Whereas endothermic chemical reactions are those chemical reactions which absorb heat energy as the reaction proceeds. All right. So please make sure that you are able to differentiate between exothermic and endothermic chemical reaction. Exo, EX, okay, so EX, exit, exo, and endo, EN, enter. So remember this, okay, let this help you to quickly remember what is exothermic and endothermic chemical reaction. So let's discuss with example. So example of exothermic chemical reaction. So this is a reaction where heat is given out, isn't it? So combustion reaction, okay, burning. So chemical reactions which involve burning or combustion are good examples of exothermic chemical reaction. So let's use the same example which we have used earlier, which is burning of a charcoal. So when we burn charcoal, what does it give you? Does it not give you heat energy? Yes, it gives you heat energy. So when you burn charcoal, it gives you heat energy. That is why the people of Koima, the people of Nagaland, during winter, we like to sit near the fire. Okay, when you sit near the fire, you are burning wood. Wood is also a form of carbon. Okay, or you buy koila, which is a form of carbon, and then you sit around the koila because it gives you warmth. So burning of charcoal, burning of carbon. Okay, so carbon plus oxygen gives you carbon dioxide plus tremendous amount of heat. So this is an example of exothermic chemical reaction. Then example of endothermic chemical reaction. Example of endothermic chemical reaction from your textbook. I'm taking this example from the textbook, which is CaCO3. This is calcium carbonate. Okay, CaCO3. Then it undergoes chemical reaction and gives you calcium oxide plus carbon dioxide. So this is calcium carbonate, okay, undergoing a chemical reaction to give you calcium oxide and carbon dioxide. Now let's do a quick revision here. Can you identify the reactants and the products here? Okay, please let that be the question. Okay, let it be the question. I want the answer in the comment box. So please give me the answer in the comment box. Identify the reactant and the product in the given chemical reaction. Okay, so tell me, what is this? Is this the reactant or the product? You please mention it in the comment box and tell me what are these. Calcium oxide and carbon dioxide, are they reactant or product? You kindly mention in the comment box. Okay, so now calcium carbonate undergoes chemical reaction and gives you calcium oxide and CO2. Now this reaction, okay, as this reaction proceeds, as calcium carbonate breaks, decomposes, okay, to give decomposes, it absorbs a lot of heat energy. It requires a lot of heat energy, okay, to break. So here heat energy is absorbed. So calcium carbonate, okay, absorbs heat energy. Only after absorbing heat energy, it will break into calcium oxide and carbon dioxide gas. So such type of chemical reactions are called as endothermic chemical reactions. Why? Because they absorb heat energy, okay, and only after absorbing heat energy they are able to proceed further into the chemical reaction. So such type of chemical reactions are called as endothermic chemical reactions. So my dear students, I hope I am able to help you, okay, understand the topics. So wrapping up today's session, today we have discussed about chemical reaction, the definition of chemical reaction, and then we have discussed about reactants and products. Then we have discussed about change, physical change and chemical change, and then the characteristics of a chemical reaction, and then the last topic, which is endothermic and exothermic chemical reaction. So we will end the video from here today. In the next video we will continue. I will be teaching you balancing of chemical equation, so make sure that you don't miss the video. Okay, so stay tuned. Okay, thank you all for tuning in, and please continue with your support. Okay, watch the video and then forward it to your friends, and then spread the what do I say, spread the good energy. Okay, spread this so spread it. Okay, just spread it. Okay, forward it, and then let your friend also benefit. Okay, so I'll see you again in the next video. All the best and God bless you all.